Okay, so work done by spring force. So suppose we have a spring given and an object is attached with it and a force is applied in this direction. Okay, so what is the work done by this force? Okay, so that we are going to see. So the expression for work is what? Force into displacement. So in this case, suppose in a straight line, we can write the displacement as x. We can write f dx. Okay, and see this external force is F. The spring force, we are going to find the work done by spring force. So spring force will be in backward direction. If you apply some external force to pull it, the spring force will be in backward direction. The work done we should write Fs dx. And the value of Fs, if we write, that is minus kx, opposite to the displacement. Okay, so we can write it like this. And suppose the string is taken from initial position x1 to x2. So x1 to x2. So what is x1, x2? I will write. So x1 is initial stress force. See, if you write the force equal to, if I write the force equal to Fx, so what is this x? The x is the extension of the string, extension or compression of the spring. Okay, so this is the initial expansion, initial expansion, and this is final expansion. Okay, so if you solve this thing, if you put the values minus k x square, if you integrate it, you have to put different values x1, x2, x square by 2. So you will get minus k x2 square minus x1 square. So this is the expression which we get. Okay. So what we can learn here in this derivation after finding this, what are the different points which we can learn? In this case also the work is path independent. Path independent means the initial and final position. The x2 and x1 are initial and final position. So how we are moving means whether we are moving slowly or we are moving with large velocity or we are moving with path, that is no immaterial. Only initial and final positions are important. So independent of path. Work is independent of path or how it is moved, that is independent, and it depends on initial and final position only. Work depends only on initial and final positions. Okay, then this is the work. Now next thing we can see that we have x square here. So if you take x square, so whether you take x as negative or positive, that is not going to affect the result. So negative positive means what? We have considered expansion. So if you compress it, the x1 will become negative, x1, x2 will become negative. So the work done is independent of whether it is expansion of or compression. Both the cases, we have to find the work done. So in what direction we are taking the x, whether it is compression or expansion, that is not going to affect the work done. Okay, so for compression or expansion, the work done expression, the work done calculation is same. Why same? Because of square, because this, since x square and x1 square and x2 square, so whether you take plus side x1 or minus side x1 or x2, it is going to remain same. Okay, so if you compress it again, the work will be negative. Means we will see means whatever work is positive or negative, but if you compress it, if there is some work done, if you expand it, the same amount of work will be there. Now we will see in which direction it is negative and which direction is positive. So if a spring is stretched, so if it is stretched, if spring is stretched, so stretched means what? The x1 will be less and x2 will be more. The x1 is initially the small expansion and then x2 will be larger expansion. So x2 will be greater than x1. x2 will have larger magnitude than x1. Okay, so that is larger expansion. In this case, the work done will be, since it is larger, the work done will be negative. Since it is larger in magnitude, you can see the work done is negative. The work done by spring force will be negative in this case. Okay. Now, if a spring is compressed, if a spring is compressed, so compressed means again, initially you will have some negative value of x1. Now you will have larger value of negative x. So whether it is if it is negative, finally you have to take a square, so it will become finally positive. So in case of compression also, work done is negative. Why negative? I am explaining it again. See, if you have, suppose a spring is there, okay, if it is compressed, suppose this is the natural position, if it is compressed by 5 centimeter, initially it is compressed by 5 and it is further compressed by 10. Okay, so initially it was compressed by 5 and now it is compressed by 10. So final is minus 10 centimeter and initial is minus 5 centimeter. Final is minus 10 centimeter and initial is minus 5 centimeter. So minus 10 square, minus 5 square. And then we have negative with whole. So again, you are going to get negative. So work done will be negative. So we will now see in what cases the spring will have positive work done. So when the spring is relaxed from a compressed position, means if a spring is released from a compressed or stretched position, if spring released from compressed or stretched position, then work done is positive. Work done by spring is positive. Why it is positive? Now you can see. Suppose it was expanded and it is relaxed now. So initial compression is, or sorry, initial expansion is more. The x1 will be more, and now if it is released, so it will try to go back. So now the spring force is in the direction of displacement. If you expand a spring and release it, so initially it is expanded and now it is moving towards the mean position. So the spring force is in the direction of displacement. So work done is positive. Or if you look at the expression, the x2 will be less now. The magnitude of x2 will be less and x1 will be more, because initially it was expanded and finally it is less expanded or relaxed position. So you will have negative, it will become finally positive. So work done will be positive in that case. Or in the same way, if you have some spring compressed and then released, if you have a spring compressed and then released, the spring will try to come back to its natural length position. So in that case also, the work done is positive.